we study heliophysics and astrophysics in NASA, and this is a great opportunity for us to learn even more and have every instrument we have out there available to us to try to understand what we're going to see for the first time in 99 years. So just very, very exciting to see what we can do here and the observations that we're going to get. Can't wait to see the science come in and all the different science we're going to get from here. So, you know, everybody's going to learn something. So you tell me what you think you're going to learn, Thomas, having been studying this for your whole career.
Well, look, my field of study is the sun, and what's really unique about this time is the opportunity to see the solar corona, the atmosphere of the sun, during the entire time of the eclipse stitched together for 1.5 hours. And the sun, of course, is important because it's the most important star. Everything we learn about other stars, we learn here first, but it's also a source of weather and radiation. And actually on board this aircraft, we have 2 instruments, one from Los Alamos and one from Space Environment Technologies, that make those very measurements of how this radiation affects us.
Yeah, and I think it's important. The more we know about the sun, the more we know about space weather, it'll help us protect our own spacecraft in the future. It'll also help us protect our astronauts as we send crew further, and our home planet in terms of what's going on here. So why don't you tell me what you think we're going to see today and what we're going to learn today through this just incredible event.
So one of the most amazing parts of this is really to see the star as a magnetic star. And what I'm showing here is actually a prediction of the space environment of the sun today by predictive sciences and 3D printed by applied physics lab. And it basically shows that these magnetic fields are there. And what's really going to be great today is we're able to test these models using observations from the ground that we normally don't have. And so this is really exciting for us.
Very good. We've got over 11 spacecraft and over 50 balloons going up. We've got airborne science like we're even doing here. On the G3, can you explain what we expect to get out of the spectrograph we're going to have here on the plane today?
So a spectrograph is basically taking the light of the sun, which is white, and spreads it into its colors. And what we're going to see is during the time of now and partial totality, we basically see during the partial eclipse, we see the radiation from the surface of the sun, the photosphere, and all colors are there. Well, when we're in total eclipse, what we're going to see is the radiation from the atmosphere that we normally really don't see that up close. And that radiation actually has 2 predominant lines. One is a really hot iron, and the other one is, it's hot because it's 1,000,000 degrees because of that magnetic field. The other one is helium, called helium because of Helios, the sun in Greek. So it was actually discovered during an eclipse, just like it today.
Very cool. So here we are, about 30 minutes away from totality. But you can explain to me what you think from a spectrograph perspective. You're going to look out the window. What are you going to see there?
Well, so for me, the amazing part really is that we're able to, of course, see our star in its beauty. And I'm already kind of emotionally touched even now. But also, we're going to see how that eclipse, that the lack of radiation, this perfect cloud that the moon makes, affects the Earth and its turbulence. I'm really going to see whether we're going to feel it up here.
Very cool. All right, thanks, Thomas, and thanks for sharing everybody out there. I tell you, about 30 minutes away, we're going to measure as much as we can here, and I'm about to fight this man for a window seat. So when you get on an airplane and you look for a window seat, get your glasses on. We're going to look out here, and we're going to wrap up here from the G3 and send it back to Solar Eclipse Central. See you guys soon.
Wow. And that's great. Amazing, yeah. Thank you to those of you on the G3 to fill us in on what you're going to be seeing from there. Here we are on the other side of the country, here at Charleston, South Carolina. I want to give a shout out to the college. The students here have been so incredibly great for us, and we are actually going to have a chance to go back to Salem, Oregon, and find out a little bit more about what they are seeing there. They're talking about this moon picture right here.
Right, we've got a live picture right now from Salem, Oregon. We were showing you earlier in the broadcast, and as you can see, as we've been sort of describing it as the moon taking a bite out of the sun, it's continuing to happen, and what it looks like, Karen, is like it's almost like the sun. What we see is almost like a crescent moon, but it's not. It's the moon is actually the black portion in the upper right-hand portion of the sun that's being blocked out as we get closer and closer toward totality, which, as Robert and Thomas said from the G3 aircraft, is only about 30 minutes away for folks in Oregon.
And we will go right to Madras, which is right near Oregon. This is another view of the eclipse. One of the great things about this particular eclipse, Sean, right, is that the totality will be over land for so long. So we're about to start seeing it in Oregon, but normally, you know, most times when you have an eclipse, a lot of it happens over the ocean, right? The ocean gets to see it.
Right. So for folks, especially here in the United States, this is the first time from coast to coast that we've seen a total solar eclipse since 1979. And so that's why for a lot of folks are talking about this being a once-in-a-lifetime opportunity. And remember, it takes about 90 minutes for the totality portion of the eclipse to cross the United States, the continental United States. So as they mentioned earlier from the G3, about 30 minutes from now to totality there, about 90 minutes to get to where we are here in Charleston. So that means what? If I'm time's right, in about 2 hours, we'll be at totality here.
And we are now going to go to Salem, Oregon, where Jesse Carpenter will be talking to Nikki Weil, a solar scientist from NASA.
Welcome back to Salem, Oregon. It is clear, but yes, it is a little bit breezy here
windy,
today.
yeah.
Isn't it? Yeah. I'm joined again with NASA solar physicist Nicolene Weil.
Hi.
Hey, so why don't we just take a look at what we've got going on here now that transit is deep underway.
Yeah, so the moon is crossing in front of the sun, and it's kind of looking like the moon is taking a bite out of the sun. And if you guys have any colanders with you, like a kitchen colander strainer, you can actually see, if you let the sunlight come through that colander and look at the shadow on the ground below you, you'll actually be able to see the projected image of the moon taking a bite out of the sun down on the ground in front of you.
Oh, that's cool.
Yeah.
So you can just get something from the kitchen and share that with everyone who you're watching this with. That's great.
That's right. Now's the time to take out your pinhole cameras if you have those, or if you have those, you know, the safety eclipse glasses. Now's the time to get these out and make sure to look at the sun with these on.
That's right.
You
really
want to be watching safely.
Enough. And I know we've been very important to be wearing these glasses.
It's just so amazing, though, to see the moon crossing in front of the sun. I mean, you never get to see anything like this.
So, are there some basics that you could share with us? I know we were trying to present some of that a little bit earlier in the show.
Yeah.
But are there some things that maybe you could talk a little bit about the layers of the sun?
Yeah. So there's sort of three outer layers of the sun. There's the photosphere, that's the part we're seeing now. There's the chromosphere and the corona above that. The chromosphere and the corona, that's the solar atmosphere. Now what's cool about today is that usually we get to see the photosphere, the visible surface of the sun. But today, during totality, we're going to get to see the atmosphere, the chromosphere and the corona of the sun. And we don't usually get to see those because they're so much less bright than the sun. It takes something special, like today's total solar eclipse, to be able to see them. So that's really amazing. We're going to get to see that.
It is so cool. So I think what we're going to be doing now is sending it back to NASA's Eclipse Central in Charleston. Take it away, guys.
Thanks.
And welcome back to Charleston. You can hear these students are really excited for us. And I got to tell you, I had the chance to interview some of them just a few days ago. The College of Charleston students are excited, and I wanted to find out what they knew about the eclipse. Let's watch the video.
All right. So right now what we're looking at on your screen is
Hello, I am Karen Fox with NASA TV. I'm here at the College of Charleston in Charleston, South Carolina, and we are going to spend some time interviewing students to find out what they know about the total eclipse of 2017. What's happening on Monday?
The solar eclipse is happening.
Monday, the eclipse.
That's the right answer, the eclipse. Are you ready for the eclipse?
Oh, I'm pumped. I've been talking about it all summer.
What is an eclipse?
When the moon moves in front of the sun.
It's when the moon passes in front of the sun and creates a shadow on Earth.
What is the closest star to Earth?
The sun? The sun?
The sun.
The sun? Yes, the sun! Very nice. Will you demonstrate for me putting these on?
We're gonna put them over the glasses.
the music you associate with the eclipse. What have you been listening to? What are you going to listen to?
Here comes the sun.
Total eclipse in my heart.
Do 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 do.
Da-na-na, like, I saved every letter you wrote me.
So I was really impressed with how much these students knew. We had a great time here. And now you can once again see the imagery we are pulling in of a white light telescope of 2 eclipses happening as we speak. These again are the partial eclipses, Salem, Oregon, and Madras, Oregon.
Right, as you can see, it's quite an image as that moon continues to progress. Transit is the term over the surface of the sun, getting closer and closer toward totality. And again, this is an opportunity for us to remind folks, regardless of whether you're watching this right now in Oregon or if you're anticipating the beginning of the eclipse from another location in the US or really across North America, wherever you're able to view us from, that it's important that you have to have those safety glasses. We cannot stress that enough. We've been getting a lot of questions on social media, people just emailing us asking about that. You must have the glasses unless you are in the path of totality and during those brief moments of totality.
Right, and Sean is stressing the glasses, but of course you can also watch the sun indirectly. There are a lot of ways. Nikki Weil, a solar scientist, just told us that you could even pull out a colander because it's got little pinholes in it. You can use a Ritz cracker that has a hole in it. The other thing is you might even see the eclipse image filtering through the space between leaves on our tree. There's some really wonderful ways of catching imagery of it. So, you know, be safe, but don't think you absolutely have to have the glasses. That is not your only option. Should we talk a little bit about the science that NASA's
we should, but
doing today,
before that, I just want to give a shout out to our website because you're talking about all these great ways to indirectly view it. And again, just a plug for the eclipse2017.nasa.gov site where you can find all kinds of information, but especially some do-it-yourself instructions on how to create some of those indirect viewing methods.
Great, we've talked a lot here about the partial eclipse. Nikki Weil, who you just heard talking, she studies the corona, that is the atmosphere around the sun. And she was telling me just the other day how excited she is that she is going to be able to see that with her naked eye during the actual total solar eclipse. So that's what's interesting. We can only see that normally from space with our space telescopes.
Right, and even with that, I was talking to one of the heliophysicists back at NASA headquarters in Washington, D.C. Recently about this, that even with those artificial eclipses that they create from the coronagraphs, they're called, in space, it doesn't give you the same viewing opportunities that we have with a natural eclipse like we're seeing now. That there's actually a couple different layers of the sun's corona. We have the outer corona and the inner corona, and because of the way those coronagraphs work, they do not allow a good image of the inner corona, the part that's really close to the sun's surface. Only the outer corona. It's only during an actual natural total solar eclipse like we're viewing today across the country that scientists, heliophysicists, and others, and just the general public are able to see the entire corona, and that really gives them a lot more information. And remember, for these scientists, no matter where they are, they only have that brief, maybe 2 minutes, maybe 3 if you're really lucky, right in the center line of totality, to see the entire corona and get those measurements.
Yeah.
So again, Karen, as folks are looking at their screen right now, you see that double image, Salem, Oregon there on the left, and nearby Madras on the right. 2 different images with 2 different types of telescope using to view this eclipse. It's still in the partial stages, starting to get closer and closer. Salem, Oregon there on the left, and nearby Madras on the right. 2 different images with 2 different types of telescope using to view this eclipse. It's still in the partial stages, starting to get closer and closer toward totality in just a few minutes.
And stick with us because we are going to be tracing this eclipse all the way across the country. Not only does everybody in the country have a great view, but we have some views from the sky, don't we, Sean?
That's right. Looking up from the ground is how most of us will experience today's eclipse, but researchers at Southern Illinois University wanted a different perspective. They wanted to look down at Earth to image the moon's shadow. In Illinois and across the United States, teams are using high-altitude balloons for a unique perspective.
Right now, they're getting ready to launch a research balloon from Saluki Stadium in Carbondale, Illinois. We're going to go back to Carbondale, Illinois. The primary payload will be a real-time, high-definition video system. So let's check in on the progress of that launch.
Holistic astronomy here, we're experiencing it on lots and lots of
Eclipse in 4D. It's just like being on the surface.
But, you know, to actually understand the corona is very important because all sun-like stars have their corona. We need to understand why the energy is released in the way it is.
All right, look, we're getting a call. We need to go inside the stadium right now. They're about to launch the balloon for the Louisiana Space Grant Consortium. So let's go to Kevin, who's standing by.
That is what's going to let that get safely down to the ground.
And all those instruments
strung out along there. Attached as well. That's a beautiful sight.
Okay, can you hear me okay? Right.
Yes. Balloon launch in less than a minute. So
this is Kevin Boucher. Sorry about the little mix-up. I was too enthralled. I was too enthralled looking at this fantastic weather balloon that has just launched. You can probably see it behind me. It is pandemonium here, but it's good pandemonium. One of the weather balloons has launched, and with me is one of the team members. Introduce yourself to the entire world. No pressure.
Hi, my name is Colleen Fava. I'm the program manager for the Louisiana Space Grant Consortium based at LSU.
Okay, so just to kind of keep a scorecard for people if they're wondering, we talked to, I guess, the program director, Dr. Gregory Guzik. He is your boss.
Yes, he is my boss.
What exactly does your job entail with this consortium?
I manage the program, so I write grants and reports and organize students and keep them on track, and I do communications training.
Sounds like you do a lot of outreach as well, and it thrills my heart, and I'm sure it thrills your heart to see so many of these young people. You probably did not have to drag these young people kicking and screaming to do this help, did you?
No, we brought 4 institutions with us, and LSU is the home team, and so they were always coming, but we actually had a competition to figure out which other students we would bring, and we brought a team of 46 people.
Okay, and right behind you now, I had forgotten they're launching 2 balloons. Now the first balloon, I think we have a video of the first balloon.
Right on top of it here, just a few more seconds.
Okay, we're getting ready to launch the second balloon.
Both of our balloons launched already. That's
okay.
The third balloon,
The first balloon, Colleen, that was launched, where is it right now? Maybe 2,000 feet, you think?
They go up about 1,000 feet a minute, so a few thousand. It's probably been a couple of minutes now.
Okay.
So.
There it goes. This other one has launched. It's a big yellow balloon filled with helium. And the next time we see this balloon, we'll be down on the ground and it'll have wonderful data. Can you tell us about what goes into studying the winds and the weather reports, trying to calculate where this will land so you can quickly retrieve it and get your data? That's a whole nother science.
Yeah, so I'm not an expert on it. I can just tell you that we do our predicts. We started our predicts months ago, doing them maybe every week or so, and then the last few weeks we've been doing predicts every single day. So we have a good idea. We think it'll go about 36 kilometers, about 22 miles due east, somewhere near Marion. So we'll have several chase vehicles kind of staged and ready to go, and I'm not sure if they decided to leave before or after totality, but we have some local people helping us to make sure we have access, and we're hoping, expecting to be a pretty easy recovery.
Now, will you actually be on the chase team yourself?
No, I'm not going to be on the chase team. I need to do logistics here on the ground. I have been on a chase though, and it's very exciting.
Oh, I'm sure. Yeah, can you tell me about it? And please get as specific as you can. What are some of the most eventful ones? Like, has the balloon ever come down in
Pontchartrain River?
How did you know? You're not kidding me?
I'm not kidding you. We did have a landing in the Pontchartrain River, which was not a great recovery, but it was definitely better than landing in the airport, which we were afraid was going to happen.
Well, I was going to say I would rather land in an airport because the Pontchartrain River, you have the water that might damage some of your instruments, but you're the expert then, right?
I think we'd rather not interfere with air traffic control.
well.
That's true. Landing in a Pontchartrain River, and I assume the alligators did not make a meal out of your several $1,000s worth of instruments?
We didn't recover that payload, but we have done water recoveries in the past, and we actually just invested in an inflatable kayak.
Okay. My producer just told me we are seeing first contact. Everybody, we have people putting on their glasses the first contact. We are seeing the first contact, and we've got about 4 minutes left. How many total solar eclipses have you seen, Colleen?
This is my first.
I assume you have your glasses. Right. Feel free to go ahead and put your glasses on.
You want a pair?
Yes, please.
If you press your fingers together, you can make little spaces in between your fingers.
If you don't mind, I'm gonna.
You can project little images of the eclipses down onto the ground. So make sure you look down just as much as you look up.
You can't really see through
also,
them.
If you
Right. Okay. My glasses are on. Are your glasses on too?
They are on.
Okay. And the sun. We are turning around. Would it be okay if I turn my back to the camera so I can see the sun? Oh, okay. I'm going to turn my back to the camera. Oh my gosh! There is a small bite starting in the sun.
That is gorgeous, is that not?
What are your comments?
I said that is gorgeous, isn't it?
Ripply shapes you see on the ground.
That is fantastic. The total solar eclipse in Carbondale, Illinois has begun. A small bite is being taken out of the sun by our satellite called the moon. This is incredible. Earlier they were telling people to talk about in one word to describe the eclipse. The word for me is majestic. A lot of times, I don't know about you, sometimes if I want to, take a break on my computer,
What's your weight balance? You're on Mongo? Well, now you got no stops.
So on the other side of the world,
Oh.
they don't. Oh yeah. Well, it was like that far up. So like I'm trying to find my iPad. My iPad. And I've got it. John.
Yeah.
Hmm? I don't know.
I'm going to bed.
I've been staring at the sun. It's been dark for the last 20 minutes.
Maybe dark permanently.
Yeah. I'm going to take a nap. I'm going to go all day.
Pick a name.
I'm sure he does.
Right here.
Run. Grant, did you take mine? No, mine. Mine was there, and I moved it over. Mine was here. I moved mine from This is the Planet Finder.
Planet Finder?
I don't have.
Well, he doesn't have Planet Finder. He has the one that we found in
Oh no, this doesn't. So if you do this. We're getting close.
I think so.
That's the thing on. That might be the left. Gabe's gonna drop 20 more. Right from when the thing started. No, is it gonna drop 20 degrees once it's complete? I know. He said it was gonna drop once this, and it's gonna be warm, and then get